Space is vast. It's filled with stars, planets and galaxies. Where did it all come from? How did it all begin? These are big questions, but we are getting closer to answers. By studying the universe, we learn about our place in it. Join me on a journey. Let's explore the incredible story of our solar system's birth. Our solar system is anything but ordinary. It's filled with planets, moons, asteroids and comets. Each one is unique. Each one has its own story. But before these celestial bodies existed, there was a cloud of gas and dust. This cloud, called the nebula, held the ingredients for everything we see in our solar system today. It's hard to imagine, but our sun, the planets, even us, all came from this swirling cloud of cosmic matter. The universe is full of surprises. As we explore, we make new discoveries. We learn more about the cosmos and our place within it. The birth of our solar system is just one chapter in an epic story. It's a story that continues to unfold today. And with each new discovery, we gain a deeper understanding of the universe's grand design. Imagine a giant cloud of gas and dust. It's bigger than you can imagine. This is the solar nebula. It's the birthplace of our solar system. This nebula was mostly hydrogen and helium. These are the simplest elements in the universe. But there were other elements too. Tiny bits of carbon, oxygen and iron floated within the cloud. These heavier elements were the leftovers from ancient stars. The solar nebula was not alone. It was part of a larger cloud. This cloud was constantly moving. Gravity pulled the gas and dust together. Slowly, the solar nebula began to shrink. As it shrank, it spun faster and faster. Think of a figure skater pulling in their arms. The solar nebula was like that skater, spinning faster as it became smaller. This spinning created a disk. The disk was flat, like a pancake. Most of the material in the nebula gathered in the center. This central clump would eventually become our sun. The rest of the material continued to swirl around the center. This swirling disk would eventually become the planets, moons and other objects in our solar system. But how did this transformation happen? The center of the nebula became incredibly dense. The pressure was immense. The temperature soared to millions of degrees. Under these extreme conditions, something amazing happened. The hydrogen atoms began to fuse. This fusion released enormous amounts of energy. A star was born. This wasn't just any star, it was our sun. The birth of the sun changed everything. Its powerful gravity held the swirling disk of gas and dust together. The sun's heat also played a crucial role. It pushed the lighter elements, like hydrogen and helium, away from the center. These lighter elements ended up in the outer regions of the disk. The heavier elements stayed closer to the sun. These heavier elements would eventually form the rocky planets. The lighter elements would form the gas giants. But before planets could form, something else had to happen. The dust and gas in the disk needed to clump together. This process is called accretion, and it's what led to the formation of the planets we know today. Section 4. From dust to planets, the solar system takes shape. Imagine tiny grains of dust swirling around the newborn sun. These particles collided with each other. Sometimes they stuck together. Over millions of years, these collisions created larger and larger objects. These objects are called planetesimals. The planetesimals continued to grow. They became protoplanets. These protoplanets were the seeds of the planets we see today. The protoplanets had strong gravity. They pulled in more gas and dust. The inner protoplanets closer to the sun became the rocky planets. These include Mercury, Venus, Earth and Mars. The outer protoplanets, farther from the sun, became the gas giants. These include Jupiter, Saturn, Uranus and Neptune. The gas giants are much larger than the rocky planets. They also have many moons. The formation of the planets was a chaotic time, but eventually the solar system settled into the configuration we know today. Section 5. Mysteries among the stars, unveiling the secrets of our celestial neighborhood. Our solar system is full of wonder. Take Jupiter, for example. It's the largest planet in our solar system. It's a gas giant with a swirling storm that's raged for centuries. Or consider Saturn. It's known for its stunning rings made of ice and rock. Then there's Mars. It's a red planet once thought to be home to life. We're still searching for signs of ancient life on Mars. And what about our own planet, Earth? It's the only planet we know of that harbors life. How did life arise on Earth? It's one of the biggest mysteries in science. Even the smaller objects in our solar system are fascinating. Asteroids are rocky remnants from the solar system's formation. Comets are icy bodies that release gas and dust as they approach the Sun. Each object, from the largest planet to the smallest comet, holds clues to the solar system's past. Section 6. Our solar system's everlasting dance. Our solar system is not static, it's constantly moving and evolving. The planets orbit the Sun, the moons orbit the planets. Even the Sun is moving, it's orbiting the center of the Milky Way galaxy. This intricate dance has been going on for billions of years, but it won't last forever. In about 5 billion years, the Sun will run out of fuel. It will expand into a red giant star, engulfing Mercury, Venus, and possibly even Earth. Eventually, the Sun will shed its outer layers, leaving behind a white dwarf star. The planets that survive will continue to orbit the white dwarf, but the solar system we know will be gone. The birth and death of stars are fundamental processes in the universe. They drive the evolution of galaxies and the creation of elements. Our own solar system is a product of these processes, and its fate is a reminder that even the most enduring objects in the universe are subject to change. What mysteries will we unravel next? The universe is waiting to be explored.